Welcome to this module, and this module is a short module where we will look at the DC offset parameters of op amp. It is also called op amp specification, and we will quickly rewind whatever we have done in this particular lecture. So, if you can come on the screen, what you see is even though the input voltage is 0, there will be an output, right. So, what you should do when you are in the laboratory, try to ground your non-inverting terminal and the inverting terminal, right, and see what is the output voltage VO, see what is output voltage VO. Ideally it should be 0, right, ideally it should be 0, but what you will find that even the input voltage is 0, there will be an output, This is called offset, The following can cause this offset. What? First is input offset voltage, we have seen, right, output offset voltage due to input offset current, we have seen input offset current, total offset voltage due to input offset voltage and input offset current, and input bias current. We have seen every parameter, and these are the parameters that will cause the offset, an offset. Okay. So, what is input offset voltage? We have seen nothing but input offset voltage, that is voltage that must be applied to the input terminals of the op amp to null the output voltage, to make the output voltage 0. You see here we are applying a small amount of input voltage such that my output voltage will become 0 when I connect both my input terminals to ground. When I connect both my input terminals to ground, my output voltage should be 0, but it is not 0. That is why I have to apply some amount of voltage at the inverting and non-inverting amplifier, so that I can get the output voltage equal to 0, that is to null my output voltage. Typically, if you come back on the screen, what you will see, typically the value is 2 millivolts and the maximum the value is 6 millivolts. Typically value is 2 millivolts and maximum is 6 millivolts. When operated in an open loop condition, right, must be nulled or device may get saturated, right, because a small amount of input voltage, the output voltage will keep on increasing in case of the open loop gain, because open loop has infinite gain as we know. So, output will be saturated. That is why before we use in a open loop or in a closed loop even, we have to always try to null the output voltage. This nulling can be done by help of the input offset voltage VIO. Okay. So, if you move to the next one, input offset current, we have seen this the algebraic difference between the input currents, right, algebraic difference between the input currents is my input offset current. These are the base currents and are usually nulled, typically value is 20 nanometer, the maximum of 200 nanometer, minimum is 20 nanometer, maximum is 200 nanometer. So, what is the technical to null the output voltage VO, right, what is the technique to make VO equal to 0? So, first is you do this thing, short input terminals to ground, you see, short input terminals to ground, we are grounded. Connect the potentiometer between compensation and VE wiper. See, we are connecting now between 5 and 1, right, what we are connecting? A potentiometer, you see, we are connecting potentiometer. Now, this is the role of your another terminals, another pins of the operation amplifier. You know there are how many pins? 8, 1, 2, 3, 4. Let us see, 1 is your we are not connected 1, right, inverting, 3 is non-inverting, minus VCC, not connected, 6 is output, 7 is VCC, right. Between 1 and 5, 1 and 5 is used for offsetting the null VO to null, and 8 is not connected. 8 is not connected. So, 1 and 5, between 1 and 5 you can connect the potentiometer, right, connect the potentiometer between the pins with wiper to VE. Now what we have to do, potentiometer is usually a 10-turn device, we know that, connect meter output and adjust the potentiometer such that my output voltage becomes 0 by connecting this to VEE, right, and then if I change my potentiometer, if I keep on changing my potentiometer, I will reach a value of output voltage VO equals to 0. I will reach a value output voltage equals to 0. This is a technique to null your output voltage VO. So, what we have seen? We have seen input bias current, right. To quickly say the average of the current that flows into inverting and non-inverting terminals, the value is around 7 to 80 nanoampere. Differential input resistance, also known as input resistance, is nothing but the resistance when you look at the input terminal of the device. The value runs from 2 mega ohms for LM741 to as high as 1012 for FE input impedance, FET input device. Output resistance between the output terminal and ground, that is your output resistance, typical value is 75 ohms or less. Input capacitance, the equivalent capacitance measured between either inverting and non-inverting terminal is your input capacitance with respect to ground, may not be on all specific sheets. So, specification sheets, when we see a specification sheet of an operational amplifier, you may not be able to see the input capacitance. Typically the value of input capacitance for LM741 is 1.4 picofarad. So, what is that? The equivalent capacitance measured at either inverting or non-inverting, either inverting or non-inverting terminal with the other terminal that is connected to the ground. Alright. So, capacitor between inverting and ground or non-inverting and ground, between inverting and ground or non-inverting, and typical value is 1.4 picofarads. Typical value is 1.4 picofarad. What is power supply range? Power supply range may be differential or single ended power supply. We have seen in the starting of this lecture, maximum is plus minus 22 volts. Most of the time what we use is plus minus 15 volts. Most of the time what we use is plus minus 15 volt, right. Output voltage swing. Output voltage swing is what? Range of output voltage, right. Depends on power supply voltage and typically is about plus minus 13.5 volts. Now, this is when your output voltage is plus minus 15 volts. So, this is how much output voltage can swing. It can swing maximum to 85 to 90% of the supply voltage. Alright. So, range or output voltage depends on the power supply voltage and usually about 85 to 95%, usually about 13.5 volts plus minus 13.5 if my supply is plus minus 15 volts, if my bias is plus minus 15 volts. Slew rate, the maximum rate of change in the output voltage in response to a input change. Maximum rate of change of output voltage with respect to the input depends greatly on the device. Higher is better, right, higher is better, and output responds faster to the changes. That means slew rate also shows that how fast my output changes when I change my input, how fast my output changes when I change my input. That is the function of the slew rate. Okay. So, now if you go to last line for LM741, it is about 0.5 volts per microsecond. For LM41 it is 0.5 volts per microsecond, and for LM318 it is about 70 volts per microsecond, 70 volts per microsecond. Okay. Finally, the gain bandwidth product is nothing but the bandwidth of the device when the open loop gain is 1. When the open loop gain is 1, the bandwidth of the device is called my gain bandwidth product. So, these are all the op amp specifications, these are all the op amp parameters or most of the op amp parameters that we have covered in this particular lecture. Alright. Our next lecture would be of using the operational amplifier for different applications like different circuits, inverting, non-inverting, differential amplifier, integrator, right, summer, comparator. So, we will see how the op amps can be used as a different circuits in our next lecture. Till then you see this particular specifications whatever I have told you, and this whole entire lecture was divided into 4 different modules if I am correct. Then look at all the modules, understand all the modules, then you will understand what are the specifications of an operational amplifier. Alright. So, I will see you in the next class, and till then you take care, and let us see what we learn in the next class. Alright, bye.